Hey everyone, thank you so much for joining this morning's webinar, which is a live kind of improvised video webinar with Markforged and SQP Engineering. We have a lot of people joining, so we're just letting everyone join and get ready to rock and roll. My name is Richard Elving. I'm the VP for Asia Pacific here at Markforged, and we have an exciting webinar for you here today, which is really about how modern CNC shops are combining additive manufacturing and subtractive manufacturing. And during today's live video webinar, you'll be getting an exclusive behind the look from one of our valued customers live here from Perth in Western Australia. So I'm very pleased to announce and introduce David Miller, who's the Managing Director for SQP Engineering. Dave, thank you so much for hosting us here at SQP. Maybe for the audience, Dave, if you wouldn't mind, give us a taster of what the audience is going to be able to see today in your factory, and what is SQP Engineering and what do you guys do?
Yeah, sure. Thank you, Richard. Well, SQP is a medium-sized production workshop. We utilize CNC machinery, robots, bar feeders. We try and produce in the hundreds to the 200s, but it leaves a little bit of question mark about the low volume items, and we'll discuss a little bit of that later on. But SQP's been around for about 20 years now, I think. We started off with one CNC machine. We've got a fleet of 9 now. Out of those 9, only 2 aren't automated. And it's a growing, exciting business. We really rely on apprentices. I've got both my sons working for me, and you'll meet them later on. We have 3 apprentices and I think TA and some metallurgical people. So we haven't got a lot of people, but we really do utilize our production capabilities automation-wise.
Amazing. So just at a high level, Dave, what was one of the reasons why you decided as a CNC shop owner to dive into additive manufacturing, right? A lot of traditional CNC shops, they're still doing maybe at the peak, they're not only doing maybe manual programming, maybe they're using CAM, but a lot of them have not dived into additive manufacturing. They're purely subtractive.
That's right. The old algebra of manufacturing is you got your subtractive and you got your additive. With the additive manufacturing, we were really looking for the low volume items that we're machining here. The amount of time it made it take, the setup time, the paperwork, everything was getting a little bit frustrating and hard. Additive did solve that. It also opened up a few new, pretty exciting ventures that we didn't really think were possible with normal manufacturing methods. And I'm talking different customers. We're talking to some food-based customers now. We're diverging. We're actually changing people's thought process on actually how they can manufacture something that is additive instead of subtractive, and it'd be just as good or even better than what they had before. And we got a few examples we'll go through later on. But most of it is, I do love new technology. It's something that fascinates me. I was pretty much the first person who went out there and brought a digital camera. Cost me $1,000, but yeah, the old Sony. But I do love technology, and this technology here is changing on a daily basis. Keeping up with it is good fun and a struggle. The new materials, new slicing programs, just everything. So amazing. Yeah, it's good.
So what I'm hearing, Dave, is that we're opening up new revenue streams. We're going into new industries, and we're offering some smart solution for your CNC shops that we will see very shortly.
Yeah.
So just for the audience, again, I know we have an international audience with us today. This is some data from the CommBank, which is an Australian, largest Australian bank, which is really showing some of the challenges and opportunities that we have in manufacturing. What this is showing is that for manufacturers in Australia and around the world, increased cost pressures is something that they see as a big challenge. Keeping up with customer needs, obviously customer demands keep changing. And a big one in many countries is labor and skills shortages, right? And every single manufacturer that I talk to, they say, hey, how do we reduce manufacturing costs? How do we optimize our supply chains? And how do we increase our speed to market? And what's fascinating is for the first time in the 20 years that they've been doing this CEO survey, is that 3D printing is now one of the key initiatives that Australian business owners are taking to overcome some of these challenges. I mean, Dave, what do you have any feedback? I mean, are you seeing or you're hearing from customers, or do you recognize that increased costs, changing customer needs, supply chain shortages? Is that something that you're seeing?
Yeah, design changes. So our customers now are specifically going out there designing around 3D printing. They know that is, or one of the big keys about it is we can print here, or we can actually print over in America somewhere using the same file. Your product's going to be exactly the same as it is here as it is over there. So they're actively looking at actually changing the design so it can be 3D printed. It's it's comforting to know. It's
Amazing.
comforting to know.
Amazing. Well, this is good to hear that this data is correct. And I think one of the key things that we in manufacturing, what we need to do is we really need to learn from the pandemic. And of course, I'm not going into politics, but we can see what's happening in the world now with tariffs, and it's the next thing and the next thing. And I think what we're realizing around the world is we really need to shift our mindset. And I think from spending 20 years in manufacturing, it's exciting that manufacturing is cool again.
Yeah.
Everyone's thinking about reshoring.
Oh, the kids love it too.
The kids,
So I employ apprentices here, and you try and keep them off these things. It's great fun. I mean, if they're not printing off items that are going to go on a drill rig, they're printing off chess pieces. Just
exactly. So I think this is really what we need to leverage. So just for you guys on the call that are new, what is it that you guys do at Markforged, and why is it relevant to CNC shop floors? Well, we are the makers of the digital forge, and this is really a platform that combines software, which is things like slicing, simulation, quality inspection, as well as 28 different materials that are proprietary for mission critical applications, as well as 11 different 3D printers for industrial use. So we at Markforged, we are really laser focused on the factory floor and producing end use parts, tooling, jigs and fixtures, end use effectors, which is what you'll see here in the walkthrough today. And every day, myself and Markforged team are out there really looking at how are manufacturers making things today. And what we're seeing is a lot of old ways of making things, which is extremely time consuming and very cost expensive. So we are here to work with manufacturers such as yourself to look at what is the new ways of making things. How do we move from design directly to 3D printing a product, leveraging a digital inventory in the cloud that can be accessible from anywhere in the world. And you can see that it's all about reducing costs. And these are some of the amazing customers that we have today in Australia that are leveraging our technology. It's anything from product design, companies that make COVID testing machines, to fitness equipment, to the architectural industry, through to automotive vehicles, into defense and aerospace, producing end-use drones, through to things like robotics and industrial automation. So the technology is used by tens of thousands of manufacturers that are all looking at improving their supply chain. An example here is that we could be sitting here in Perth at SQP today, hosting a digital inventory, and essentially we can connect with suppliers, contractors, employees at Dave's different customers around the country. Even at mine sites, they might have a part that is needed. And essentially we can connect all of this through the digital forge to a digital inventory. Rather than keeping physical inventory, we can produce the parts on demand. And Dave touched on it. He said the kids love this. Well, this is why we at Markforged are investing heavily into partnerships with universities around the world and in Australia. Here in WA, some of the key universities like Curtin, Murdoch, ECU, and as well as on the East Coast are all leveraging Markforged technology because it's really about teaching the makers of tomorrow, right?
They're coming out of uni already programming themselves to 3D print instead of going down the old route of saying, well, let's get this block of material and let's turn into a $20,000 block of material. No, let's 3D print a $2,000 bit of material. So it's the way they actually have to think now. And if they don't think like that, it's going to go, the job's going to go.
Cool. That's well, you heard it from Dave, right? And just lastly, guys, last few slides before we do the walkthrough. We are very, very proud to work with the AUKUS across Australia, the UK, and America as the official partner for producing tooling, fixtures, and end-use parts on board submarines. So the Australian Navy are endorsing our technology, which is, if you're a defense supplier, it's very, very difficult to get these kind of endorsements from the defense. And this is certainly an industry that you're seeing a lot of increase from the defense.
Yeah. I mean, we are starting to dabble our toe on it. It's pretty big, exciting happening down at Henderson, which is a port up the road there. And they've got an information hub there as well. We're going to be privileged to actually have a talk with the guys later on about how they're utilizing additive manufacturing, scanning, different solutions to provide real world solutions as well, not just in the Navy. So it's good. It's that combination of information.
Amazing. So guys, again, for you guys that are new at Markforged, what you'll be seeing today is the world's strongest plastics and nylon components, as well as metal parts. The secret sauce is the continuous carbon fiber, which is the proprietary to Markforged, which is essentially embedded inside of the nylon and plastic components, making our technology and our parts 25 times stronger than any other 3D printed part on the market. And some of the printers that you'll be seeing at SQP today is everything from a print farm of small devices, the Mark IIs, through to the mid-range, the X7, through to our latest and greatest device, which is the FX10, which is the world's first metal and composite printer, as well as what we call the Beast, the FX20, which prints up to 0.5 meter parts, producing aerospace and defense parts in high temperature material. So we hope that everyone on the call today will appreciate that this is a very much non-rehearsed live walkthrough of a factory floor. So if you do have questions, guys, there is a Q&A tab that you can use. Obviously, we will save the questions for the end where we'll come back and sit here. But what we're going to do now is we're actually going to take you live onto the factory floor. We're going to look at some of the applications first here in the office, and we're gonna kick it off.
Yes.
So you excited?
You're
excited. Okay, so what I think I'm going to do here next is really introduce Markforged technical specialist, which is really going to help drive some of the conversations with you, Dave, on the factory floor, who knows more than anyone on the team here than about Markforged and some of the key applications. So with that, I would like to introduce Michael Tuckey. So Michael, you've been with Markforged how long, and what do you do at Markforged?
Yeah, so hi everyone. My name is Michael Tuckey. I'm the technical lead for Markforged Asia Pacific. I've been working with Markforged machines since 2018, so 7 years or so. I've been working with Markforged directly for the last 2 years or so. And yeah, I head up the technical team for Markforged Asia Pacific. So thank you very much for the introduction, Richard. And all right, let's take a look at some of the applications.
Where do you guys want to start?
Well, we'll have a look at a few bits and pieces.
Yeah.
Maybe explain a little bit about SQP and what we produce here and the size of work we produce here. We don't make our own product. We make everything for our customers. And to do that, we need a large variation of tools to do that with. The printing comes in there, absolutely valuable to that as well. We have some specialized machines out there that obviously we do our CNC machining, just a little cut one of our customers wanted a little cup, so we're making little cups. I think they were handing them out at the end of the year. Down to our 3D printing. So some of these products here, we just thought they were pretty cool, so we chucked them in the cabinet. But what spun me out first time when we first brought the FX20, which we'll see later on, is that we managed to print this fan.
So it's a fan blade, isn't
It's a fan blade, okay, and it's as thin as it comes. And that was printed without any support or actually any raft.
Yeah.
And I did it as an experiment to see how good is this printer really. And wow, it blew me away. Absolutely blew me away.
It's fantastic. So Dave, there's quite a range of different applications in here. So we can see we've got certain parts that are made from onyx.
Yep.
They're Markforged proprietary carbon fiber filled thermoplastic, and then as well as some metal parts here, Dave. So speak about some of the metal parts, especially these medallions. It's absolutely incredible.
So we were lucky enough to sponsor the world's windsurfing event that happened a couple of years ago. I said, if I'm going to sponsor it, I want to make the medallions because it was a pretty cool event. So these are 74 pH stainless steel 3D printed medallions, and they have been absolutely, that's coated in pure gold. So even though when you print these things, your after processing on them is so user friendly. I can even weld these together if I wanted to, just with stainless steel, normal stainless steel welding.
Yeah, so these have been produced on the Markforged Metal X system and then coated in gold, silver, and bronze.
Yeah. And we printed 70 sets. So I had that table all full down there. It was quite an experience and quite a challenge, but it was great fun to do. It was great fun to do.
Brilliant.
Even as I said, I might have mentioned on the chest sets. So these were another example. When I first grabbed the Metal X, once again, I said, how good is this? How is it going to go? Where's my learning curve? So we decided to grab something like this and print it up. And as you can see, it's come up really good. Absolutely perfect. That's really fine detail.
Yeah, yeah. So that would have been printed on the fine features mode of of the FX of the Metal X.
Metal X.
Yeah, yeah, in 17.4 stainless steel as well.
Yeah.
Oh, and also, Dave, so you mentioned the ease of post-processing the metal printed parts.
Yep.
So this is a great one. If you could speak to us briefly about this.
Well, this was just an experiment at the end of the day. We printed up two lugs, and we just decided to
closer to the camera.
Let's see how well this welds together in case we need to do some post-welding or something like that. Well, I won't say I've tested it, but welds are pretty good.
Yeah. So as we've established, the metal printed parts can be heat treated, they can be coated, they can be plated, and as we see here, they can be welded as well.
So most of the time, this is another printed mold. So this mold is a polyurethane mold. We've also done them out of the Ultra material, which is done on the FX20. We tried this one first, but we found it was actually more cost effective to do it out of the Ultra material. But this is a simple little procedure. That's all made in one piece. And this is the only removable part in it, which is attached down to the bottom there. Manufacturing that, impossible. Printing it, pretty simple.
Fantastic. And this, again, is 17.4 stainless steel? Yeah.
It sounds like here, Dave, that we're making components and parts that are essentially impossible, or you wouldn't even try machining it. That's
you wouldn't try. Or you probably maybe get there, but you would have to assemble, and you have to put bits and pieces together. And this is a mold. As soon as a bit of glue or a bit of gunk gets into the cavity, it's defective. It doesn't work too well. So this is also goes to the point that once you do your metal printing, your post machining, if you need to do it, it's just post machining. You just chuck it up there and drill and tap, or clean up the surface, or make an O-ring perfect. It's something that we do all the time.
Beautiful. Cool. Thank you very much. So behind us here, we have two X7s, which are part of the part of Dave's manufacturing fleet here. So Dave, they're currently producing a part with an interesting story. So you'd like to share that with us?
So this part here, I think I've actually shown to a couple of you guys before. This is just a bracket. And this bracket is designed to protect an instrument that sits inside it. It goes on a drill rig. The interesting thing about this, when you print stuff, it's also light. So if it goes on a drill rig and there's a lot of vibration, there's a lot of energy going towards it, a lighter piece of equipment is going to last a lot longer. But we were asked or tasked with the point of machining it. I said, look, I'm not machining tuning cones. I'm not machining bits and pieces. They just kind of come up with a very bad finish. Then they said, well, let's get a bit of metal and let's see if we can press it. So we tried pressing it. It came up okay, but it wasn't absolutely perfect. This needs to be absolutely 90 degrees to this. And then I actually said, come on, we need to print it. We need to print it. And this is interesting because the guy says, no, printing, no, we don't want to print. So I said, damn it, I'm going to print the one. I'm going to give it to you. And then you tell me. So I printed one up and it goes, oh, wow, that's so bloody good. I'm going to do this forever. And we've done hundreds and hundreds of these. Completely changed the way they looked at how they did their manufacturing, how they did their processing, how they did the design work on these drill rigs. Because as I said, weight matters when it's hanging around.
Yeah, fantastic. Thank you for sharing that, Dave, because that's it's a common story that we do here in Additive. Sometimes you'll have people with a bit of apprehension about whether or not the printed part is going to be strong enough or with a great enough surface finish to be able to be utilised in their product.
That's right.
So,
and they do.
Yeah,
and they do.
Slowly but surely.
It takes a bit of convincing, but also with the features of Iger's features, I could print this solid. I can print this with a 80% infill, and it's all about cost for them at that stage. So I can tune it into their desires, strength-wise and cost-wise.
Fantastic. So we'll keep moving. We'll transition over here to this area where we have our latest and greatest FX10 printer. All right, so we'll do a few on-the-fly camera adjustments here, just make sure we can see everything. All right, fantastic. So, Dave, FX10, so the most recent machine acquisition with SQP. You talk to us a little bit about the FX10 and why this was a product that you wanted to add to your additive manufacturing fleet.
Well, as you said, I do like technology. So when it came out, I said, oh, yeah, I've got to try this one. So really, actually, to be honest, it comes down to we are getting quite a few print jobs now. This thing prints how much faster? 10 times faster, was it?
Yeah, up to twice as fast as some of our other machines.
Yeah. So anyway, the print time was definitely a consideration, but ultimately it's actually the 316 stainless steel that actually pushed it across the line. It's we do a lot of work for the marine industry. Marine industries are very reluctant to change their materials. If they say 316, it's going to be 316. So this opened up a few more avenues that I can actually go to the engineers and say, how about we print this? And they go, right, let's give it a shot. So, and they're coming on board. Coming on board.
Fantastic. And as we see at the moment, we have onyx in this machine. And this is something that's very unique. The Markforged FX10 is the world's first composite and metal printer. So Dave just mentioned 316 stainless steel. And that is part of the product offering for the FX10. So metals and composites all in the one machine.
Yep.
So Dave, also we have some parts up above here. So you speak to us about
the food grade nylon.
Food grade nylon.
Yeah.
So a recent release to the FX10 is NSF certified food grade nylon. And Dave, perhaps you could speak about how that is appealing to some of your customers in the hospitality and food and beverage industry.
Yeah, sure. So we just happen to have a sausage maker across the road and a pie maker up the other end. We're in current talks with them now, trying to get them on board with this food grade material. Once they again realise the savings, realise what they can do with it, they don't have to worry about their molds or their cutting instruments or their bearings or their pulleys. We can actually go down the food grade system, actually print them up for them. They don't have to keep a holly for spares. They don't have to worry about running out of materials. It's a solution that I think will fit really well. It also opens up other opportunities. Where we're in Perth, we're typically an oil and gas mining situation. Food industry, well, everyone eats, so there's food industries everywhere. That's something that opens up a little door as well for us, so we can actually investigate manufacturing, printing for them as well.
Yeah, fantastic. And what we've found at Markforged is there's been a huge demand for food grade materials, because the food and beverage industry, as we all know, it's a multi-billion-dollar industry, and the food grade material is really paving the path forward for us into that industry. All right. So from here, we've had a look at some of the machines. We've spoken about some applications. Shall we continue on with the tour and go and look through into the factory floor and see how SQP are utilizing
we can have
utilizing printed parts for your own internal applications?
Well, that's right. I mean, obviously we print items for our customers, but when it comes down to manufacturing, our fixtures, our jaws, even our tooling, we're actually printing them as well. So, yeah, well, let's have a look.
All right, beautiful. Let's go.
After you, gentlemen.
So this machine here, I think if you can actually see, it's an Akuma Maltus. It's a big, strong machine. We couple that with a Panic robot on our side, and it's the robot that we're interested with today with our jaws. So these are all 3D printed jaws. So right now, we're manufacturing, picking up and loading billets of this size down here. They're not a small weight, but they're a weight. We have other jaws that we've printed off. I mean, for example, these jaws here. These are picking up about 40 kilo blocks, swinging around, chucking them in the machine accurately and efficiently every time. Never dropped anything. So this is a Onyx solid print. We could have put carbon fiber through it. I have done a few carbon fibers, but the solid does it anyway. So it's actually quite a strong material. Coupled with that, we actually printed off some little washers. So when it bolts in, the bolts don't pull through. So this is just a safety feature for the bolt. And they work really well. So,
yeah, so fantastic. So you're utilizing. So what we're utilizing there in that part we just looked at, Dave, is essentially it's a hybrid part where we're taking the benefits of both the metal printing and the composite printing, putting it together in one part.
You got to do it. You got to do it. Yeah, it's great fun.
Yeah.
But as I said, this robot is a 125 kilogram robot, and I wouldn't hesitate to put a lifting equipment or plastic on there.
Why, Michael, do we print end user vectors or like why are they printed rather than the machine maybe?
Yeah, machine. Oh, definitely time. So I'll show you a couple of other machines out there. They're production machines. They run constantly. We are trying to get to a state where our lights out manufacturing, 24 hours manufacturing with automation. No one's going to go up there and break that machine down just to make some jaws. If they do, it's going to cost them a fair bit of money. We used to do it. I've got some jaws out there that we've machined up. But after getting them printed, so I'm not going backwards. So everything's printed from now on.
Yeah. So the key there, Dave, is for you to, so you could machine a set of jaws, but that would mean taking a production system off a customer's job.
That's right.
Offline to make one set of jaws, and then only to put it back online and resume the job that's making.
That's exactly right.
Yeah.
And then when you start printing, you can actually start printing. This is not a highly complex part, but you can print complex parts. So if you're picking up forgings, fixtures that have different shapes and sizes in them, you pretty much get your jaw, put your mold on top, subtract it, print your jaw. It's pretty much that simple. Especially with the Iger.
Yeah.
I mean, as I said, the kids pick it up. I even picked it up, so yeah, it's pretty good.
Yeah, so you just touched on something here, like some of the challenges, I guess, in the CNC industry, which is not often talked about, which could be the setup time, or right, which could be one area, right, and then the other area is, of course, you want to use your CNC machines for producing revenue for you, for production time.
Yeah, my customers happy. Yes.
Yeah, absolutely. Fantastic. So we have another
module or zone over
Yeah.
there that we're going to take a look at as well. That you're in the process of setting up. It's a new.
This thing's here is
New system?
it's a game changer. This is putting our milling capabilities through the roof. So yeah, let's have a quick look.
All right.
After you, gentlemen.
So this system right now is in its infancy. It's just getting assembled. It's been a year in design and collaboration with ASA and Akuma. But the interesting thing about this is it's got so many firsts in the world. So the robot is the first in Australia. The chucking system's the first in Australia. Even the machine's first in Australia. So we're pioneering a fair bit here. But let's have a look at some of the stuff that's been printed on it. This is a typical draw system. What will happen here is that we will stand outside the cell and place our product into the drawer. The robot will pull the drawer back in, take that part out, machine it, put the finished part back onto the table. But also, just as practicalities, you print these things up every day of the week. You wouldn't even bother chucking it on the machine. It's a little locking system, a little tag system. That's on all the drawers. So just even little bits and pieces like that saves some manufacturing times. You know it's going to work. They're all going to be exactly the same. All the precision's exactly the same. You don't have to calibrate anything. It's just going to bolt on. It's going to be really nice. Should we squeeze through?
We can have a quick looky-loo. Yeah, why not? What are some of the reasons? Like, why are you investing in automated cells like this, Dave?
Well, at the end of the day, if we're going to be lights out manufacturing, there's little chance we're going to do that successfully if we're going to man it up. Our pay rate is probably the most expensive in the world. If you don't go automation, you're going to go broke pretty quick. It's starting to tag along a fair bit, especially with the robots and the brains of these guys down here with ASA. It's becoming a jobbing shop type adventure now instead of a full-on production type adventure. We can set up items in here that will just have 3, and we'll use the robot to load and unload and organise all that sort of system, say to load up the first 3, and then the next job or the next 5, the next job or next 10, fully automated. And if you can do stuff like that, you're on the right track. So this is the first robot in Australia. It's a brand new Panic. It's a new design, new capabilities. We have the Greswold system over here. This basically stops you from having 100 to 200 vices loaded up with material. These Greswold systems will actually grab the vice, it will pick up the material, it will put the vice into the machine, it will machine it, it will pick up the vice. We've got a changeover system just behind here, which will a 6-sided system, which will flip it over, it will chuck it back in the machine and it will do what too.
Well, it sounds like you're investing in a lot of automation.
Investing a lot in automation.
Yeah. My apologies. Okay, we're back.
So not only are we actually loading up the Akuma MU500, we're also loading up the NV56 next door. So this machine will be running both machines 24/7 pretty soon. They're doing a hell of a job, but we'll get out of their way for now.
How many CNC machines do you have, Dave?
Yeah, we've got 9 now. As I said, the only 2 that aren't automated are the first 2 machines I brought. I started off around about 20 years ago and brought my first machine and kind of loved it. So I brought another one and then, got out of hand, brought the rest. So, yeah, it's great. It's good fun. I've got both of my kids working for me now. So, so one of them takes over all the machining side and the other one takes over additive side. So, it's good. I separate them, so yeah, they keep them keep them honest. Here's a few other interesting parts that we've got out here, these are utilized on a vacuum plate. So a vacuum plate is basically exactly what it says. It's a suck down motion. And then we've printed up these little items that take care of orientation. And when the vacuum's on, it sucks it down and it stabilizes. So when we machine the top, they don't fly off. Very hard to hold plastic sometimes and not crush it. The crazy thing about this is when these items are done, the thickness on these are down to 50 micron. So that's really plus or minus 25 micron. So if this fixture didn't have that accuracy, at the end of the day, we would have scrapped all these parts. It's comfortably known that it's actually that accurate.
Yeah. So obviously, Dave, this is quite a large part, and you were just speaking about quite high accuracy and levels of precision. What machine from your fleet did you utilize to produce this part?
Yeah, right. So this is on the FX20. This is about 2 years old. Sorry, this part here, and it's been surviving. It's been in coolant. It's been out of coolant. The FX20. I think the heat stabilization helped a lot to keep the true thickness constant all the way through. It's quite a winner.
Fantastic. Should we continue on through? Have a look at some more parts here.
So this is us just trying to, I guess, store collets. If you've been in the machine shop before, there's just the 40 collets. They usually end up in the bottom of a toolbox, floating around on a bench top somewhere. Quite obviously, we printed up simple structures that hang on to the nooks. And so we load them up. So you put all those collets together. There's a little bit of weight. There's not a lot of weight, but it takes control of all our start of our 5S, which we are slowly working through.
Yeah, fantastic. So we're seeing the manufacturing be utilized to provide products to your customers.
Yep.
To provide jigs and fixturing for your own internal systems.
That's right.
And now even storage and more automation and things like that for your
So everyone knows exactly where to go when they get some collets. As I said, they're not spread out across the workshop, even with the little ones. So it works well.
All right. So the next stop on this journey, I believe you're going to show us some more of your print farm as well as the Metal X systems.
Sure, let's
Should we continue on up? Do you want to speak about this bay before we continue on? Or
yeah, well, let's have a quick look.
Yeah.
So this is a unique machine. I'm a bit of a hoarder. I buy all Akuma machines and I'll buy all Markforged machines. I'll buy all the same tooling. It's good to get representation of a solid build. If I brought 5 different machines, I'll have to learn 5 different languages. I'll have to get along with 5 different suppliers. It gets a little bit crazy and out of hand. So I've always been a stippler. If I'm going to go down one track, I'm going to stay on one track. So this Akuma machine here has got a bar feeder on it. It's also got a robot attached to it. So this one here, if anything under 80 mil diameter will be bar fed through the machine, it will be machined. And then we punched out anything over 80 mil. This is the same robot that we had in the other cell. We'll line it up down here and we'll actually use the robot to load and unload. So this is quite an interesting cell.
Amazing. Shall we head up?
Yeah.
Well, it's fantastic to see a nice, clean factory floor and full of automation.
Just you, Richard. Just
Amazing.
So we'll walk upstairs.
This is behind the scenes, guys. Live from the factory floor.
Yeah, so up here we've got our 2 mil X's. We've got Center 1, Center 2. I've got another Center 2 here. We'll install that later on in the year, I believe. And if I can introduce you to Hudson, Hudson's my son, and he takes care of all our additive.
So yeah, as you can see in the background, we've got two of the Markforged Metal X's. These machines are really awesome. They can do 630 stainless steel, also known as 17.4 pH, copper, A2 tool steel, D2 tool steel, and H13 tool steel, as well as Inconel 625. And I said copper. Yeah. And yeah, so every CNC machinist knows that Inconel is a difficult material to machine. So this is where these printers really shine. We're able to print 90% of our part, with excluding our seal faces, our high tolerance dimensions, and then we're able to put it into our CNC machines to finish them off. So it takes a lot of the legwork out of removing material, breaking inserts, breaking tools, ripping hair out.
Yeah.
And it just makes our life a lot easier when we're doing those materials,
And cost effective.
and cost effective as well. So we're, as well as allowed to print copper. So we're able to print impossible to machine geometries. That is impossible to machine geometries. So we're added extra airflow and extra surface area for better heat transfer here.
Fantastic.
Yeah.
So thanks, Hudson. So we can see that that part there is orange in color, but it doesn't really look like copper yet. Could you speak to us about the process? So the printing is the first step of a three-step process.
Yeah.
For how Markforged manufactures metal.
So yeah, there's 3 steps. So after the part's been printed, we then need to wash it. We wash it because it's got wax and glue inside of it. These waxes and glue hold metal dust particles together. It leaves a certain percentage of behind, otherwise it'll turn into a big pile of dust. After that, we confirm that it's lost its required weight for a cleaner sinter run. So, and these are the sinters. So we've got, like Dad said, we've got sinter 2, which has a build volume of this. This is the build plate, or sinter plate. So we're able to sinter quite large things. And then we've got a sinter 1, which is a bit smaller. So we're allowed to sinter fewer parts, smaller parts, but at a much better cost-effective rate. So we like to use this machine for our copper, our Inconel, and tool steels runs, since there's not that much of demand. But this we run through all of our 17.4 pH, our 630 stainless steel.
You can load it up.
And we've loaded it up and loaded it up. Yeah.
Well, Dave and Hudson, I mean, what we are hearing in the field from a lot of CNC shops is, you know, they are not interested in a lot of low volume work, the one-off,
Yeah.
you know, in Australia at least, right, for the audience. So, I mean, is that also something that contributed to the choice of investing, in metal printing? Like, and I mean, what else would customers do, right?
That's right. Yeah. So it's it put us in a position, quite obviously, low quantities. You hope lead to high quantity, but getting that low quantity across the bridge, the prototyping, if you like to put it that way, the way that the customer might interact with it and change it or completely change its mind, and doing one-offs like that down there, it's tricky. But you do it. But if I can print it, if I can actually get it to come out and give it to them, and they go, wow, this is exactly what I'm after, let's go in production. So that's definitely the target we're looking for. I sometimes don't look at these as a prototype and one-offs to us. I think of these also as mass production. So we were just doing a batch of widgets, 400 at a time.
Yeah.
So it was an interesting one too, because if I was to manufacture downstairs, 200 is a good number for me. I would manufacture downstairs. 90% of that material was in the bin. It was actually more cost effective and more easy for us to actually print them up here, sinter them, and get them out the door.
Fantastic. So one of the questions we often get with the metal printers is around accuracy. How accuracy are the parts? I think this is a great example. We could show the people on the call, and perhaps Dave, you could speak to this. So what we see here, we've got a onyx printed carbon part around the outside, and then a really tight press fit
stainless steel part in the center of it. So you can
Yeah.
speak to us about this part, please.
So that's right. The customer came up to us and wanted us to machine this, and we said, no, we're printing it. And we'll come up with a design with you. They'll explain it a little bit better. So this part always stays on the item, and it's got a hex on it. So when they're ready to run and tighten up the valve, they chuck a pair of spanners on it and they tighten it right up. But if they want to do it nice and quickly, they just slip the wheel on and spin it up. But what impressed me was we have done nothing. We've just printed these. We've done absolutely nothing. No sanding, no posting, post processing, no nothing. And like that, it's pretty extraordinary.
Really,
Yeah,
really,
it's really good.
yeah, really impressive. So when it comes time that you do need to machine a printed metal part,
Yep.
What are the scenarios where you would need to machine, and how does that process look from
Yeah.
a production standpoint?
Yeah, absolutely. Well, Hudson sort of broached on it before. Sometimes if you have small threads, small tap holes, you've got to be careful of that.
Yeah.
Printing design is always advisable that you actually have a good look at your printing design and the ways that you actually do your design for printing. But if we had like a high precision O-ring face or a high precision sealing face, we would probably just leave a little bit of green on it, Hudson.
Yeah, so in the modeling state, we'll have excess material on it. So the printer prints what it can see. So we'll print it as normal as we want. We center it as normal. And then the fourth step is just bring it down to the machines and just take 0.1, 0.2 off. Yeah.
So we've got 10 minutes. We want to talk a little bit about the production farm here.
Yeah. So as we see here, we've got another area of SQP's print farm where we've got a large amount of desktop machines that they utilize for higher volume production.
That's right. So these things have been bulletproof. They've been around for a few years. We don't generally have any problems with them. We are using, since we've got the FX10, we are using that a little bit more now to take a bit of pressure off these machines here. But that just gives us more capacity here. So we'll print any day of the week on these things.
I mean, here with essentially you've got 6 printers here, which can all be run in parallel, Michael,
That's right.
Or
That's
in a
exactly
day,
right.
which
So
is-
we got the largest amount of printers in APAC, I'm pretty sure.
Yeah.
Yeah.
So, how do you find this amount of machines and the throughput they're able to get? So, say, for example, if a customer comes in and wants 50 of this part,
Yeah.
how rapidly are you able to produce it with that with a farm like this?
Well, quite obviously you load them all up and you let them rip, but it's the comforting fact that you can. So sometimes someone will come up and says, "Can you do this?" The worst thing you can tell them is no. That's not in my vocabulary. I won't accept that as an answer. I'll accept, mate, let me give me my best shot. Let's get going for it. But it's about having the available capabilities and the structure and the reliability, the material selection. It's got to tick quite a few boxes. A little print farm like this works pretty well.
Fantastic. So we've seen quite a few machines, we've seen many machines so far, but there is one elephant in the room.
Oh, yeah.
By elephant, we mean elephant.
Yeah, let's go. Let's have a look at the big girl.
All
Please. You come down, Hudson? So this here is our metrology room. We do a lot of our final inspections, and we've also got the FX20 sitting in here as well.
All right. So this is Markforged's largest product offering, the FX20. So aptly named the Beast.
Yeah.
And this machine is really tailored towards high temperature materials that are utilized heavily by aerospace defense type applications.
That's right.
As Richard mentioned right at the start, the large volume production that this machine is capable of, 0.5 cubic meter,
Yeah.
thereabouts.
It's in the same build size. We were pretty much, I think we were the first person in Australia to grab one of these.
You were, yes. Yeah.
This little part that we put in here, this is actually out of new material, Vega, which is a PEC material. This was a good story, actually. We just did a miniature one to make sure that everyone was happy. The material is quite expensive, but it is so unique. So it is more of a thermal type plastic, but the applications that we used it in was actually an acidic application. The customer came to us and said, machine one up. I said, no, I'm not machining one up. I'll print one up, but I'm not machining one up. Normally you'd probably do this out of a stainless steel because of the situation that it was going in, a really acidic dam. They needed it right then and there. They actually designed it. They come up with a really nice design, very, very printer friendly. We printed it off. They trucked it on. They won the contract. Everyone was happy. So that was done in a matter of days. Yeah, matter of days. So you try and stainless steel weld that thing up and get something that looks decent. So their customer looks at it and says, "Well, that looks good," instead of something that's horrible. Yeah, that's the way to go.
And so I'm sure people are wondering on the call, what is this part? So this part is a machine guard. We might have an even larger one.
No.
Yep. So it's a machine guard that goes on a piece of equipment for the mining industry.
Yeah, that's
I
right.
believe.
So it protects some pulleys.
Yeah, protects some pulleys, and the equipment that it goes on gets submerged in a highly acidic bath, essentially. And the unique properties of Vega, this material that's printed on the FX20, one of the unique properties that's been utilized here is its acid resistance or chemical resistance.
What do you got there?
Yeah. So this is something off my own design. This is a shipping box because we, obviously, since we're a CNC machining company, we produce parts for customers. Now, the parts that go in here are very expensive and of a high-grade material and easily dented. And we had a mishap with our shipping courier. They rattled the box around and all of our parts came dislodged. A customer received it, wasn't happy about it. So we came up with this design and idea of literally slipping in each box, and we printed up a lid and you just tack it down or bolt it down. And then there's your shipping box. A box holds 50 parts and it can only really be printed in the FX20. Yeah.
Fantastic. So the parts that this box is protecting, it sounds like you've gone to this sort of effort. There must be quite a bit of value in those parts that you were protecting. Could you speak to us about that value and
Sure. So this material is pretty much unattainable. You got to wait 6 months for it to come in. It's I think about $30,000 sits in this box here. Up, was it? It was 50. Oh well, $50,000 sitting in the box. So the customer, I'm sure, is more delighted to know that we can provide a solution once again to a problem problem that could actually occur.
Yeah.
So what we're going to do, I think we're going to go back to reception and we're going to open it up for Q&A. I'm sure there'll be lots and lots of customers, right, that have, hopefully enjoyed this amazing tour of SQP.
Sure. Fantastic. Let's go.
This is just the back room, just to finish off, right? This is where a lot of the
brain's
it's where the magic happens.
Cool. We'll just sit down here. Okay. All right. We're back where we started, guys. So, hey, I want to take the opportunity to really thank Dave. And at the same time here, I want to really open it up for questions from anyone on the call who might have some queries about Markforged and SQP. And just while I do that, again, I want to just reiterate, how do you get in contact with us at Markforged in case you got questions around the materials, you want to know more about the printers, then the easiest way to get in contact with us, please send us an email at apacsales@markforged.com. And Dave, for all the companies around the world that want to get in contact with you, what's the best and easiest way of doing that, Dave?
I guess so, yeah. So it's the company's called SQP Engineering. I named SQP Engineering out of 3 problems that I picked up in my previous lives. getting good service, getting good quality service, and getting your product at the end of the day. So I picked SQP as those E tags to design and build a business on. So yeah, sqpengineering.com.au.
Got it. There's your business card.
There's my
So
business
show it quickly. So again, I just want to summarize for everyone on the call. We heard about some of the challenges in the manufacturing industry, such as labor shortages, supply chain challenges. We also heard a bit from Dave again, how CNC shops struggle with low volume work, fast delivery, programming, producing a lot of the soft draws, end use effectors, and of course, business conditions scaling up and down. And hopefully you've seen over the last hour how Markforged technology can help address those challenges, and how modern machine shops like SQP are embracing Markforged, the latest and greatest in automation, robots, Akuma, to really be a manufacturer that's ready for any challenge that might get thrown at you. That's kind of my key takeaway here, Dave. That your machine shop, you can handle these challenges and whatever specifications and jobs that might come at you.
Yeah, and a Markforged machine comes directly at the base of that as well. So it's all about being able to tell the customer what he wants to hear.
Fantastic. So guys, please do use the Q&A chat here for the last few minutes to ask any questions that you may have. So hey, I'm going to take a question here, which is asking about some of the precious metal. And I don't know if you want to grab a chair or you come in here, Mike. We're all comfy. So we had a question around like some of the materials. Maybe Mike, just talk a little bit about like what are some of the materials that Markforged offer, and do you offer things like gold and platinum? Again, maybe you want to talk just briefly to the audience what materials we offer.
Yeah, so those two materials that Richard just mentioned are metals. So I think it was mentioned earlier on, the Metal X system that we just looked at prints 3 different grades of tool steel, so A2, D2, and H13, Inconel 625, copper, and 17.4 stainless steel. The FX10, in the upcoming metal kit release for the FX10, we're adding 316 stainless steel to that.
Fantastic. And here's a question around can you talk a little bit about the food grade material? What does that mean? And someone's asking even if it's biodegradable, but I don't believe it is, but maybe you want to just talk, what does food safe and food grade mean?
Yeah, so no, thankfully the food grade materials is not biodegradable. That wouldn't hold up too well in a production environment if it was biodegradable, but it is NSF certified. So NSF is an individual certifying body, and the material meets their NSF certified food grade standards. That's the key takeaway there. That it's certified by an independent body.
Here's a couple of questions for you, Dave.
Yep.
One, which is really here, how did your business and your company overcome or create a mindset shift from traditional manufacturing, traditional thinking, to incorporating 3D printing? Like, and have you struggled with this? Has this been difficult?
For me, to be honest, not at all. As I said, I employ a lot of apprentices. It's the young mindset that actually takes these challenges automatically. So they're born with an iPhone these days, aren't they? So they actually get the understanding of actually how you can actually change your mindset on actually manufacturing a different way. To me, it was quite exciting getting my son involved in it. I got my young lad doing subtractive and my oldest boy doing additive. It's sort of blended in quite well. We started off our printing journey before Markforged, I must admit. I think when these kids were quite young, I think the up machine.
Well, it's quite common that manufacturers, they start with low cost devices for visualization purposes, and then they decide to move into
this industry that we're demanding for is engineered.
Yeah,
it's got to be an engineered plastic. It's got to be an engineered machine. It's got to have its strength. It's got to have its reliability. Without those factors, it's really, really hard to actually push to your customer saying that this is your product that's going to make you happy.
there was a question from Conrad here, which was really about, do you believe that these investments that you're making and this machinery will help you attract workers? And do you think that it will help retain staff? And I guess that's both 3D printing and the robotics, right?
Yeah. Nobody wants to work in a boring factory. Nobody wants to sit on the machine, just press that green button. I've done it. I hated it. It was boring. I wasn't going to put my kids through that. So as soon as I put an apprentice on, they're jumping on the machine. They're learning their CAN system. They're learning IGA. They're learning softwares. They're learning printing. And they're bashing down the door to get in here. So we got TAFE lecturers ringing us up saying, oh, this guy's good. You got to have him. So you get the TAFE lecturers on board. They actually advising you which kids have got the right aptitude, if you like, to actually come in here and be a real contributor. So we just chucked a new one on now. You should have seen this gleam on his face when he walked in here.
Well,
and why wouldn't you? You're playing with fancy robots. You're playing with fancy machines. It's great.
Well, I'd say, I mean, the interest is massive. Just on this call, we have hundreds of people on this call live with us now. This afternoon, we have an open workshop for local manufacturers where we have, again, few hundred companies attending. So I'd say that, I mean, the noise is out there, and hopefully this will help result in more business and more workers and happier workers.
Oh, yeah, happier workers. That's the thing.
We had a couple of questions here around training. So maybe and design for additive manufacturing. Do you want to take that question, Michael? Like, do we provide training, and how does machine shops, design for additive manufacturing, or how do you do that?
Yeah, absolutely. So for us at Markforged, that's a huge part of it. It's a new technology. We need a robust and intuitive training system to be able to go alongside that, because it's just a key pillar of new technology. And that's something Markforged offers through the system known as Markforged University. It's a full comprehensive training course that utilizes basically gives a full overview of designing for additive. And I think Dave, you probably speak a little bit more.
Yeah, that's pretty much the first thing that we did when we got the Markforged printer. I think we got Hudson sign on, or didn't I, Hudson?
Yeah.
So sign him on. It's well for me, it was a learning curve. Just to tell you the truth, these guys here pick it up pretty damn quick. Once again, youth, they're just pretty good at this sort of stuff. So it's also about educating your customers, which is sometimes tricky, sometimes not. Sometimes they get it, sometimes they don't. But more and more now, they're actually looking at it and saying, if we don't do this now, our competitors are going to be doing it, and then we're going to get blown out of the water. So it's one of those easy conversations to have with some, that they need to actually change a mindset, get into it, have a look at it, see the benefits. It's an education at the end of the day.
Well, I think that's what we talked about in the beginning. This is what I'm seeing after 20 years in manufacturing. It's about shifting the mindset.
Yeah.
And you said it multiple times during the tour, like, hey, we don't have a choice, right? It's really about embracing technology. It's really about leveraging robots, leveraging 3D printing, machining, because the old way of doing it is just not going to work for the next decade.
It's not cost efficient anymore. It's not cost efficient.
Yeah. Okay. So then I guess here's a general question, like, how do you convince your customers to print? I assume that that's what you just said, which is really about educating and sharing information with your customers. Is that right?
That's right. So as I said before, sometimes seeing is believing. I always believe that as a good opener. If I am having trouble with someone to jump on board, I'll just print it for them and give it to them. I say, hey, look at this. Feel the strength in it. Feel the test in it. Yeah, exactly like we're talking about this blue part here.
So here's another question, like from Raymond. Thank you, Dave. What advice would you give someone who's looking at starting a similar business, their own engineering firm or a CNC shop, and they haven't done any printing? What advice would you give them?
So really, I mean, it's a trade. The job that we do is a machining trade. So I'd be jumping off getting my machining trade first, but at the end of the day, doing additive manufacturing is an anytime thing. There's courses in uni now, I believe. There's SolidWorks, Fusion. Most of them, they've fairly good. Am I right in saying that they're fairly good at actually keying into these additive manufacturing situations? AI is something to really have a good gander at. It's getting your first foot started and just following the rest. At the end of the day, you just, if you don't dip your toes, it's going to be a little bit difficult.
Here's a question, which again, I mean, I don't like to point out other brands, but here someone's asking specifically about low cost 3D printers, which I remember the first time I was here, before you had any Markforged, they did have a 3D printer. And again, not to point out other brands, but I remember what you guys told me in that very first meeting, right? About the quality and the level of parts that machine was printing. So that's really what they're asking. So again, we won't call out brands, but they're one of the questions was really about other 3D printers.
Yeah, so the reason why we went with Markforged instead of any other company was because when we printed on their printers, it's going to work when you press print. There's nothing you can really do to upset the machine. The machine's already been designed and engineered, and the material's already been designed and engineered. Same with all the slicing software settings from Markforged themselves to just work. So you have the confidence of putting down a $300, $400 print, pressing go, and it just works. There's no troubleshooting needed. There's nothing.
Yeah.
And then the surface quality improvements from our previous machine was day and night. Yeah, it was insane.
So what Hudson's actually getting on about this open source software that you can get, you can change everything. You can change the color of the light fitting. I mean, you can change everything. But what that does, gives you ultimate power, but it gives you the ability to have classic failures.
Yeah. And here, I guess the follow-up question just came back, that do you still use that machinery? I personally haven't seen it. So yeah, okay, hopefully you didn't just remove it from me. So Mike, back to you here. Here's a question, general question. Like, what kind of cost savings can you see from leveraging additive manufacturing? What have you seen in general in the field?
So look, fantastic question. And it's not uncommon, well, it's more common than not to see an order of magnitude price savings when transitioning from a traditionally machined metal part to a printed solution. So the cost savings are very apparent. Dave, I'm sure there's probably some specific instances you could speak to.
Yeah, well, I mean, you saw a couple of fixtures out there. You saw a couple of jaws that we printed up. As I said, I had to break down a machine. The material cost is going to be material cost. The setup time, those jaws might cost me a couple of $100 to machine up. They'll probably cost half that price to print, but it's not really about that. It's actually about stopping that machine from doing what it's supposed to be doing. If you really chucked the rule at it and actually really figured out the cost of doing that, you'd be in the thousands. And that's like a no-brainer. You just got to print.
Yeah, so essentially you're seeing there like an order of magnitude reduction in cost.
Yeah,
and
then my customer doesn't get his product. That's a fail.
Yeah,
so,
yeah.
Well, guys, I mean, we are 10 minutes over time. There's lots of questions coming through. Please use the APAC sales at Markforged to send in your questions. If you left your name, then of course I'll get back to you. From us here at SQP and Markforged, Dave, thank you so much. Hudson, thank you.
Thank you.
Guys, we appreciate your partnership, and we look forward to be working with you. And I'm sure we'll be back for future events and future webinars.
Absolutely. Great fun.
Cool. Thank you guys there.
Thank you.
Really appreciate it. All the best. Bye.